what we're going to look at is just some basic. Have you ever heard of the book Innumeracy? Anybody read that? Innumeracy. It was written in the 80s, 90s, and what it was is a book about people don't understand what numbers mean. So if somebody asked you what $1 trillion is, you'd say, oh, that's a what? What's a trillion? A lot. Okay, that's not real helpful, is it, from a numerical standpoint? A million is 1,000 thousands. That's what a million is. A billion is 1,000 what? Millions. A trillion is 1,000 billions, or you could say a $1 trillion debt is 1,000,000 millions. So when you're starting to look at those huge numbers, it helps to have a context to what things are. A trillion is 1,000,000 millions. A million is 1,000 thousands. Okay? 1,000 is 10 times 10 times 10, or 10 hundreds. But you start to understand numbers better when you put them into groups. Well, he claims that the biggest misconceptions in math are in probability. That's why there are so many successful gambling places. You would not go to a bank and you would say, okay, here's $100, but you go ahead and give me back 60. Would you do that? No, you wouldn't do that. Here's $100, give me 60. But that's what people do with casinos and lotteries. Essentially, it's a 60% payout. So there's no way you're even going to get more than that. And we'll talk more about that tomorrow. But anyway, this is a great one. If there's 70% chance of rain on Saturday and a 60% chance of rain on Sunday, is that a very high chance of rain on any of those days? Is that very high? Would you say it's more or less than 50%? More? More or less than 70%? No, if it's more or less, yes isn't really an answer. More. You think it's more? Is it more than 80? Is it more than 90? So when somebody says this, if we're looking at what are the chances of it raining on one of those days or both of those days, you know, people don't have a concept of what that is. Watch this. If it's going to rain on both days, the chances of both days are 0.7 times 0.6. It's raining on this day, then it's raining on that day. Does that make sense? So that's 0.42. So to rain on both days, almost 50% chance it's going to rain on both days. Now, to rain on one of the days, it has to rain on Saturday. That means it's not going to rain on Sunday, which would be 0.4. Or, oh, by the way, what word or means what operation? Add. Or it could be raining on Sunday, which is 0.6, and not raining on Saturday, which is 0.3. Now, this is 0.28, and this is 0.18, which adds up to 0.46, right? 46. Okay? Now, neither day, how would you figure that one out? Neither day. 0.3 times 0.4. It's not raining on this day and it's not raining on that day, which is 0.12, which is crazy because these two, this is raining on one day, this is raining on both days, this is raining on no days. You know, look at that. That's 88% chance of raining on one or both days. It's going to rain this weekend. Sorry. Okay. But you wouldn't get that from the numbers, would you? It doesn't look like it has that big of a chance. When we look at conditional, what we're looking at, if something's happening, the other situation is it's not happening, or both happening, or whatever. And this is really helpful. The chances of raining on the weekend is 88% from that. That's pretty cool. All right, so conditional that we looked at is what I call a restricted total. So if you're, and the best example of that is if you roll a dice, what are the chances of rolling a 6 if you know the number's even? So 1, 2, 3, 4, 5, and 6. Which ones are even? Two, 4, and 6, right? So 2, 4, and 6 are even. And then what are the chances? So we don't even care about these anymore. Thus, the restriction, probability of B, even. We're looking for what are the chances of rolling an even 6? Well, an even 6 is the intersection of even and 6, which is this. So it's 1 out of 3. And that's essentially what conditional probability is it's an intersection of 2 over the total. Okay? So we looked at this example yesterday or Friday where we said, let's say you have probability of A is 0.4, probability of B is 0.3, and the union is 0.5. So the probability of A union B is going to be the probability of A plus the probability of B, but there's an overlap, and we don't want to count it twice. So we subtract one of those intersections. So if the probability of the union of those is 0.5, A is 0.4, B is 0.3, you should be able to figure out then what the intersection is. So it's going to be 0.5 minus 0.7 equals negative probability of the intersection. Can you see that this is just going to be 0.2? 0.2? So that's going to be in there. Probability of A is 0.4, so if this intersection is 0.2, this will be 0.2. If this is 0.3 total, this will be 0.1. What will be out here? Point what? 5, yeah. Thank you. So now we can figure these out once you have your Venn diagram. And by the way, this is what you would see on an AP or an IB test, is they're going to have Venn diagrams with these conditionals. But you're not going to fret, because all this means is it's the probability of A intersect B over the probability of B. Or this one is the probability of B intersect A, which is the same as A intersect B, over the probability of this guy, A. Last one is going to be the probability of A not intersect B over probability of B. You go ahead and figure those out.